Hello guys, welcome back to a new video. In this video, we'll be solving sample problem 4A and then we'll be solving practice 4A. Before we begin, I want you to take two notes. Whenever you have h, you will be using this equation. H is height. You will be saying delta U is equal to PE, okay? Whenever you have velocity, then you will say delta U is equal to KE, which is kinetic energy. You know, you have memorized that potential energy is equal to mgh and kinetic energy is equal to 1 over 2 mv squared, which is mass times velocity squared. Now, we have sample problem 4A. An arrangement similar to the one used to demonstrate energy conservation is shown at right. This one. A vessel contains water, paddles that are propelled by falling masses turning the water. This agitation warms the water and increases its internal energy. The temperature of the water is then measured, giving an indication of the water's internal energy increase. If a mass of 11.5 kilogram, we have our first given, mass is equal to 11.5 kilogram. Folds 1.3 meters, so you know this is measured in meters, so this is height 1.3 meter. All of the mechanical energy is converted to internal energy. By how much will the internal energy, so this is asking for what? For delta U. Delta U is equal to what? Of the water. Now guys, I told you, I just gave you a note. Whenever you have height, use this equation. Delta U is equal to PE, which is potential energy. Delta U then will be equal to mgh. Mass, which is equal to 11.5 times gravity is equal to what? 9.81 times height, which is equal to 1.3. Yes, 1.3. Now multiply all of these and you get what? You get 147 joule. This is what? This is delta U. Okay, this is sample problem 4A. Now, practice 4A. In the arrangement described in sample problem 4A, how much would the water's internal energy increase if the mass fell 6.69? So here, height has changed. Height is equal to 6.69 meter. Gravity then will be equal to a 9.81. And mass hasn't changed because this is sample problem 4A. And mass is equal to 11.5 kilogram. Okay, use the same equation. Delta U, which is internal energy, is equal to PE, potential energy. Delta U will be mgh. Then delta U will be what? Will be mass. 11.5 times gravity, 9.81 times height, 6.69. Then this will be 755 joule. Okay, careful. I told you that whenever you have energy, it means the unit of it is joule. Okay, now a worker drives in a 0.5 kilogram spike into a rail tie with a 2.5 kilogram sledgehammer. The hammer hits the spike with a speed of 65 meters per second. Now you know, you remember the note. I told you whenever you have velocity, you will say delta U is equal to KE. Now, it says if 1/3 of the hammer's kinetic energy is converted to internal energy of the hammer and spike, how much does the total energy increase? Now, guys, careful, it is only the spike, sorry, the sledgehammer that is moving. The spike is not moving, so we are not going to be using the mass of the spike. Okay, sorry, the mass of the spike, we're not going to be calculating it. We are just going to calculate the mass of the sledgehammer. If you ask why, because it is moving, and here we are trying to use kinetic energy to find internal energy. Now guys, mass is equal to 2.5 kilogram, which is the sledgehammer. You have velocity, meter per second. Velocity is equal to 65 meters per second. Okay, now remember the equation I asked you to use. Here, of course, it is asking for delta U, which is internal energy. Delta U is equal to KE. Okay, but we have something else. It says 1/3 of the hammer's kinetic energy is converted to internal energy. So not all the kinetic energy is transferred to the is converted to kinetic energy, to internal energy. So what we'll be doing here, we will say delta U is equal to 1/3 of kinetic energy. Okay, then this will be what? From this we get 1/3. Kinetic energy is equal to what? It is equal to 1/2 times mass times velocity squared. Okay, then delta U will be what? Will be 1/3, and then you have times 1/2 times mass, which is equal to 2.5, and times velocity, which is equal to 65 squared. Don't forget the squared. Then multiply all of this and you get what? You get 1.76 times 10 to the power of 3 joule. Or you can just simply say 1.76 kilojoule, okay? Because kilo is 10 to the power of 3. For this question, you can do something else. You can first find this one and then multiply by 1/3, which is the same thing basically. Question 3, it says a 3 times 10 to the power of -6 kilogram copper. We have mass, which is equal to 3 times 10 to the power of -3 kilogram. Okay, penny drops, a copper penny drops a distance of 50 meter. You know, this is height. Okay, you have meter, so 50 meter to the ground. If 60% of the initial potential energy goes into increasing the internal energy of the penny, determine the magnitude of that increase. Again, I told you if you have height, always use this equation. Delta U is equal to PE. Guys, we have something else again. It says 60% of the initial energy goes. So you should divide 65 by 100 and you get 0.65. Okay, then you can say delta U is equal to 0.65 PE. Okay, then PE was equal to what? PE was equal to this is multiply mgh. Okay, now delta U will be equal to 0.65 times mass is equal to what? It is equal to 3 times 10 to the power of -3 times 9.81, which is gravity, times height, which is equal to 50. Now you get what here? You get 0. Delta U, multiply all of this and you get 0.96 joule. Okay, now we have the last question, which is question 4. Okay, the amount of internal energy needed to raise a temperature of 0.25 kilogram of water by 0.2 Celsius is 209.3 joule. How fast must a 0.25 kilogram baseball travel for its kinetic energy to equal this internal energy? So it says how fast. Okay, first of all, let's write the givens and then we will solve. Mass is equal to what? It is equal to 0.25 kilogram. Okay, then we have what? We have delta U. It says the amount of internal energy needed to raise a temperature of 0.25 kilogram of water by 0.2 Celsius is 209.3 joule. This is what, guys? This is delta U, 209.3 joule. How fast must this is the same mass as this one, so you don't have to write it again. How fast must an 0.25 kilogram baseball travel for its kinetic energy to equal this internal energy? So guys, this is asking for what? This is asking for velocity. Okay, it is saying velocity is equal to what? Okay, velocity is equal to it. It says how fast. Okay, obviously this is asking for velocity. Now, in only one equation we had velocity, which was kinetic energy. So we will say delta U, and we have internal energy too. So we will say delta U is equal to KE. Okay, delta U is equal to 1/2 mv squared. Okay, now let's write the givens and then we can solve the question. Okay, delta U is equal to what? It is equal to 209.3. Then this, you can write this one as 0.5 times mass is equal to what? I mean this one, 1/2 times 0.25, which is what? Which is the mass of the baseball, times velocity squared. We don't have velocity. Okay, now multiply all of this and you get what? Let's write this one down. You get 0.125 and then times velocity squared. Okay, then you want velocity alone, so divide this by 0.125 and divide this one also by 0.125. Cancels, and then you have velocity squared, which is equal to 209.3 divided by 0.125. Now guys, as you know, we have squared here. Okay, what we are going to do, we are going to take the square root for this one and take the square root for this one. Okay, take the square root for both sides. This one cancels with this one, so you have velocity, which is equal to 209.3 divided by 0.125. Then divide these two numbers and then take the square root of it. You should get 41 meter per second. This is what? This is the velocity of the baseball. This is it for today. In the next video, I will be solving the section review of this section. See you in the next video. Please, if you have any comments, make sure to write them in the comment section.